Okay, so the first thing we want to do is recap how to convert from fractions into decimals. Now there's two strategies we can use. So I'll do the first example is, let's say you have 2/5 as a fraction. Well, it's very convenient to just write it as something over 10 or 100 or 1,000. So in this case, if you multiply it by 2/2, we get 4/10. 4/10 is 0.4. The other way to convert from a fraction to a decimal is just to do a division. So 2 divided by 5, we can add a few zeros here. So how many 5s in 2? That's 0. Bring the decimal up. How many 5s in 20? It's going to be 4. There's no remainder, so we can just stop there. And that is going to give you 0.4. So you should now convert the following decimals into fractions. Pause the video now, and then we can go through the answers in a minute. Okay, so hopefully you've done all of the questions here. The first fraction, hopefully you didn't need to work that one out, 0.5. And then 4½ is just going to be 4.5. Then you've got 1/8. This is a common fraction that you should be familiar with. It's going to be 0.125, and 5 1/8 is 5.125. 1/3 is going to be 0.333, goes on forever, and 6 1/3 is 6.333, and that goes on as well. 9/11, if you do the division, you're going to get 0.818181, and then 7 9/11 is going to be 7.8181 ... So hopefully you've got these right. If you didn't, you need to go back and practice the conversions before you continue. So from these conversions, you can probably tell there's a few different types of answers you can get here. So 0.5 just stops at 0.5. You've got these special cases which kind of go on forever, and then you've got various patterns as well. So there's 3 different types of decimals that we're going to look at: terminating, recurring, and irrational. This lesson focuses on recurring, but I'm just going to give you a couple of examples of terminating decimals. So if you go back to the previous slide, 0.5 is called a terminating decimal because it stops after the 5. The 4.5 is also terminating because there are no numbers after that. It's just 4.5. There's no further digits. 1/8 is also terminating because it stops after the 5 here, and the same with 5 1/8. And some more examples of terminating decimals, you can have 0.32, 4.89, 0.004, and so on. Now recurring has a pattern that repeats forever. So the example here, the first recurring decimal you came across was 0.3 recurring. So that's just going to be 0.3333 and so on. You can also get different variations, for example 0.484848 and so on. You can get numbers before the decimal too, so 200.494949. You can also get different patterns as well, so 4.821821.821. And sometimes the recurring part doesn't start straight after the decimal. So for example, you could get 3.284444 ... and that continues. So that's recurring. And for irrational numbers, you may have come across pi before, which is 3.14159 ... Now this doesn't continue, it doesn't have a pattern. It is a completely random, we haven't discovered any patterns to it yet. So that's just random numbers that go on forever. Numbers that you might come across at A level, E, which is 2.71, and then there's a pattern after that. And there's a few more examples, but we're not going to look too much at irrational numbers in this. We're just focusing on recurring. So you may have been familiar with this notation already. I'm just going to go through the idea of the little dot that you have on top of the recurring digit or digits, whatever the pattern is. So in the first example, 0.79739 recurring is going to be written as 0.73 and then the 9 just repeats forever. And usually we show the fact that this repeats either with that little dot on the top or dot 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 like that. And it should be kind of clear and apparent that the 9 is the thing that's repeating. This is not going to be 0.73999973999. If that was the case, you would put another 73 just to make that clear at the end. This is going to be 0.7, and then we've got 2 dots. The first dot tells you when the pattern starts, and the second dot tells you where it finishes. So this will be 0.7393939 dot dot dot. And then you can have digits in between where the pattern starts and finishes. So this will be 0.739739739 and so on. You can have a single or many digits before the pattern actually begins. So in this case, it would be 0.87391, 7391, and so on, 7391. And then finally, in this case, you've got a few digits that do not repeat in a pattern. So that's 0.2385, and then 7 is the recurring part, and so on. So this is the familiarity with the notation. You will never get a digit that repeats after the second dot. So for example, 0.43 recurring, you can't then have a 6 after that. This is not possible because it's the 3 that repeats forever. You can't then have a 6 at the end of forever. So that would be wrong. You need to spot your mistake if you ever come across anything like that. Here's the same exercise, just clearly showing you what the repetition is. Okay, so it's your turn to have a go. Write the following 5 questions, the first 9 decimal places for each of these. Take a moment, pause the video, and then I'll go through the answers. Okay, so hopefully you have had a go with these. I'm going to show you the answers to these questions. So this is just going to be 0.123456789, and then don't forget dot 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 at the end. This is going to be 0.712712. Oh, sorry, that's wrong. 0.712 and then 121212. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 digits, 9 decimal places. The next one will be 0.45 is the only recurring part. So it's 1, 2, 3. It's 9 decimal places. For the next question, we're going to get 3.05 recurring. And then so on. And then for the final one, 0.1025, 10251, and then dot dot dot. Okay, so a quick true or false. Decide if the following is correct or wrong. Here's your first question. 0.6 recurring is equal to 0.667. So that is false because the 7 is rounded at the end. Unless you are asked to round it, that wouldn't be correct. So that's false. 0.38 recurring is equal to the following. Okay, so that is going to be true. 0.29 recurring, true or false? Okay, so we can see that the dot on top of the 9 is the only dot on there. So this 9 is the only bit that's recurring. This is false. This should be 0.299999 recurring. True or false? 3.025. And hopefully you've spotted that the 25 is the recurring part. The 0 doesn't repeat. So it should be 3.025252525. So that 0 is where the mistake is happened. And finally, true or false, 0.739 is equal to the following. Okay, so that is 0.7397. Well, the 3 disappeared here, so this is false. The start of the pattern is 7, then 3, then the 9. That 3 doesn't go missing. It's not just the 7 and the 9 that recurs. Hopefully you've got all of those correct, or you've corrected some misconceptions as we went through those. Okay, so in the next video, we're going to actually look at how we can convert from recurring decimals into fractions rather than fractions into decimals, which is what we've looked at so far. See you in that video.